I'm going to talk a little bit about something that we don't often consider when we talk about herbivore culling. And I don't know who of you guys went to the movie last night in the Boma, because in one way I'm very happy about the movie because it provided very nice context for my presentation. In another way I'm not so happy about it because 45 minutes of great cinematography to tell their story, and here I'm standing with my slides. But I've reduced it to one slide. Okay, so last night's movie, if you didn't watch the movie, so this is an interesting study that they've done in the Serengeti, where they actually looked at how the wildebeest numbers after the rinderpest increased, and you can see it increased from 300,000 up to about 1.5 million wildebeest. And when they overlaid that data with the fire history of the park, they saw that there was a nice correlation or a negative correlation. So as the herbivore numbers increased or the wildebeest numbers increased, the fires became less prevalent. And that is because of the conclusion they made was that this was a cascading effect of the disease actually influencing the herbivores, which then influenced the grass layer, which influenced the fires. So I was interested to see what's the effect that managers can possibly have in terms of fire through the herbivore route. So if you look at this graph here, this is showing you the megaherbivore biomass in Kruger for, pointer, great, thank you very much. So you can see that the elephant, buffalo, and hippo numbers in the Kruger National Park was pretty much controlled for. And the managers were incredibly effective. Look at that line there, of a dynamic species, with droughts and everything in there, but they kept it at about 2,500 kilograms per square kilometer. And then in 1994, culling was seized, and you can see that it increased up to over 5,000 kilograms per square kilometer. So my question was, from a management perspective, what happened to the fires? Think about the Serengeti system. Yeah, we're just not having wildebeest. We're looking at mega herbivores. What they don't show in a movie is conceptual models. Okay, so what one can do in a conference is you can have conceptual models, and people still hopefully enjoy that. So this is our conceptual model. The conceptual model is that as rainfall increase, the grass fuel, the fuel load also increase. Okay, that's not rocket science. That might still make it into the movie, in fact. If you have less than about 400 millimeters of rainfall, you have less than 2 tons per hectare generally in savanna systems. Of course, soils influence it, etc., etc. But then fire is mostly switched off. Okay, so fire is switched off with less than 400 millimeters of rain. Over about 650, 700 millimeters of rain, you would typically get about 4 tons per hectare, and fire is essentially switched on, a continuous fuel bed. Okay, so then you will have fires. But then there's this very interesting area between 400 and 700 millimeters, where the herbivores can possibly remove enough of the fuel load to switch fires off. Okay, so that's where we're interested in that grey area, because there you've got 2 switches, a switch, an on and an off switch. Okay, and what we were interested in is, from a management perspective, have we actually switched the fires off by the cessation of culling? Okay, so I only have one slide on methods where I sort of combine the methods and the hypotheses, because we want to get to the results and the management implications. So we compared annual percentage area burnt. So we've been mapping fires from the 1940s in the Kruger National Park. And we want to see what happened between years of low herbivore biomass and years with high herbivore biomass. Okay, that's a relatively simple idea to do. Most of my research focus on these simple ideas. So the hypothesis linked with that is that the annual percentage area burned would be lower during years with more herbivore biomass. Okay. So if you've got more herbivore biomass, we imagine that we switch off the fires potentially. Then we also, that's the temporal analysis. Then we also want to look at it spatially. So look at different distances from rivers, okay, because these herbivores are quite water attracted to water sources. We've got GIS data to show, well, we all know that sorry about that. So if we go back to the conceptual model, what you can imagine here is also that in more arid systems, you would, with fewer herbivores, you would be able to go below the threshold and effectively switch fires off. And with, in more mesic areas closer to the 700 site, you would actually need, more herbivores. So that's the third hypothesis, that the herbivore effect would be more pronounced in the arid landscapes than in the semi-arid and then in the mesic landscapes. Okay. And this is quite fortunate in the Kruger National Park that we've got these rivers from the north, which is more arid, towards the south, which is more semi-arid and mesic. Okay, so that's about where our three different river systems that we are looking at in this study, where they sort of fit on. So it's sort of a nice natural experimental design to test some of these hypotheses with. Okay, so let's go to the results. I'm just going to first explain to you how to interpret these figures, because we're going to have some more of them coming just now. So this is on the left-hand side, you're close to the rivers, and then you move further away from the rivers to the right. And on your y-axis, you've got the percentage area burned. Okay, so that's the two things on the axis. Then the blue bars are the years for low herbivore biomass, and the what is that? Burgundy colored is for high herbivore biomass. Okay, so and then we repeat it for the arid system, the semi-arid. So this is around the Levuvu and Limpopo rivers. For those of you that know the park, this is around the Letaba and Olifants rivers. And this is around the Crocodile and Sabi rivers. Okay, so you can see obviously the bars are higher for the mesic systems. It burns more frequently than the semi-arid, than the arid. But what I really want you to see in this slide is that the blue bars are higher than the red bars. Okay, so effectively for the years where we've had higher herbivore biomass in the system, the fires are more frequently switched off. Okay, so we've got less fires in the system. So that's our first hypothesis, which seems to hold true. So now, if you take the burgundy bar and you express it as a percentage, or the change from the blue bar to the burgundy bar, so that's the percentage reduction that the herbivores have inflicted, or between the two, the low density and the high density, if you follow, then you get this graph. Okay, so I'm going to take you through that as well. Again, from left to right is close to rivers, far from rivers, and this is the percentage reduction in area burnt under high herbivore biomass. Okay, the blue bars for arid, burgundy for semi-arid, and green for mesic. So that 5 minutes I'm going to take with a pinch of salt now, because we've lost some time with the power off, so if I'm allowed. So what I want you to see here is basically that the blue bars are high, so a lot of reduction, and then it goes down. Similarly for the burgundy, and similarly for the green. Okay, so closer to the rivers, the herbivore effect is more pronounced. Okay, so more to the left, the bars are higher. Okay, because there's more herbivores, they eat more grass, and hence there's less fires. So that's the second hypothesis, which seems to hold. And then thirdly, I want you to check at a distance, the blue bar is higher than the burgundy bar, which is higher than the green bar. Okay, and that essentially shows that the herbivore effect was more pronounced in the arid landscapes than in the semi-arid, than in the mesic. Okay, so in the arid landscapes, the herbivores quickly switch the fires off. Okay, especially close to the rivers. And in the mesic landscapes, they're eating, and only close to the rivers, where they're in high densities, do they switch off the fires. Okay, and then as you move away from the rivers, the system is just too productive, okay, and the fires are not effectively switched off. Okay, and this is just to put it in some sort of management domain. So this is the percentage reduction in fire since culling stopped across all the rivers. Okay, so what you can see from this graph effectively is that since culling was stopped and the herbivore numbers have increased, we've switched fires off more frequently than it used to be, and also that effect is stronger closer to the rivers. So this is an interesting graph in the literature that was done, very nice work by Gareth Hempson, showing the mean annual rainfall on the x-axis and on the y-axis for the black, the median grazer density. So this is for different locations in Africa. And then the grey is for fire, the median percentage burnt. And you can see how it responds to the rainfall gradient. There's a lot to talk about here, which I won't go into. What I just want you to see is that Kruger had less grazer biomass than you would expect compared to the rest of Africa, and more fires than you would expect. And that might potentially be because we culled those megaherbivores and actually, in that way, increased fire and reduced the herbivore biomass. So because of the nature of this conference, I want to put quite a bit of emphasis for the last 5 minutes of my presentation on the management implications. So we need to really integrate fire and herbivore management. Okay, you can't have a herbivore management plan that doesn't consider fires, and I'll show you just now why the opposite also. So there's this beautiful graph, well, it's my beautiful little pictures here, but this, the intelligent part was developed by William Bond, the artistic part by myself, about the green world where it's resources that drive productivity. And then you've got this consumer world, which is called the black world, if fire dominates, and the brown world, where your brown herbivores, like your buffalo, dominate the system. Okay. So what it seems like is that in Kruger, we actually have a bit of a knob of turning fires on and off through the herbivores. So you can actually move between these between a brown world and a black world. Okay. So Kruger is not a black world and it's not a brown world. It's got these gradients of it. This is just to show that it also happens the other way around. This was also work done in the Kruger National Park that was published last year, which was really interesting, where they put small fires into the landscape, and then they left the rest of the landscape not burnt, and then the animals came to those small patches and they heavily grazed those areas. They did it for the next year, and then they got grazing lawns and they switched off fires, okay, because the herbivores switched off the fires. So they actually use fires to pull in the herbivores to then switch the system and then switch off fires effectively. Very nice paper. And this is the concept of pyrrhic herbivory. We shouldn't be thinking about fires and herbivores as separate. We should actually see it as one process, pyrrhic herbivory. This would also not have made it into the movie, but it made it into my presentation. It's just a conceptual model to just show that all these things are actually connected. Okay, so what happens with grazers influence fires, and this influences the herbaceous biomass, which influence the woody dynamics, which influence ecosystem patterns, etc. Okay, so this is just to say that these changes of herbivore management in Kruger impacted on the grass, which impacted on the fires, which then impact on lots of other dynamics in the system. I think this also shows the importance of having these grazing or these gradients in the park. So you shouldn't be putting waterholes everywhere in the landscape, because now we've got a gradient of close to the rivers. You've got more herbivore-driven systems, more a brown world, as you can see in the background. And then as you move further away, you go more into your black world. Okay, so then you've got this heterogeneity in terms of where the different processes place out differently. So you wouldn't want to put in lots of waterholes in here and homogenize the system in that way. And then finally, since we're up against the elephant session in the hall next door, if you check the presentations that's going on in there, all of it is about the effect of elephants on trees, which is about 50% of their diet. Okay, and I think we need to actually think of elephants as mega grazers as well. Some of the isotopic work that's been done in the Kruger Park show that they about 50% of their diet is grass. So they actually consume a lot of grass, and I don't have it in this presentation, the data, but you can read the paper. Elephants were actually the most significant driver of switching the fires off. So this is just for us that work in the savanna systems and think about elephants to also consider the impacts on the herbaceous layer. Thank you very much. And there's the paper came out earlier this year. If you're interested, it's the same title as my presentation. Thank you very much.